Hello students, welcome back to today's class on real numbers, and in that we are going to discuss about SURDS. In the last class we have discussed what are rational numbers, what are irrational numbers, and also we have discussed a couple of laws of exponents, and once again let's try to discuss what are exponents, some laws behind that, and then we'll move forward to what is a surd. Right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So yesterday we have discussed some laws of exponents, right? A power m into a power n is a power m plus n. A power m divided by a power n is a power m minus n. A power m into b power m is ab whole power m. These are the main important laws that we're going to use in many of the problems which are linked with exponents. A power 0 is 1. A power m whole power n is a power mn. A power minus m is equal to 1 by a power m. Right? These are the most important laws of exponents. We have a couple of other exponents which will be derived from one out of all this. Right? So these are the major things, and we also discussed a couple of problems yesterday. So one or two once again just for a quick reference. A power m into a power n, which is a power m plus n. A power m into a power n, the formula is a power m plus n. So it is 2 power 2 by 3 plus 1 by 3 and 2 power 3 by 3, which is equal to 2 power 1, which is a 2. Right? We discussed all this yesterday. In the same way, 125 can be written as a 5 cube whole power 1 by 3. So 3 and 3 gets cancelled. Right? The same way we have discussed 2 power 1 by 16 whole power 4, 5 power 1 by 7 whole power 4. All this we have already discussed in yesterday's class. So that's the reason I'm not covering now. If you have any doubt, just go through the previous class. Okay. So we have discussed 25 by 27. 25 is 5 square whole power 1 by 2 by 27 is a 3 cube. 3 into 3 into 3. So 3 cube whole power 1 by 3. So 5 power 2 into 1 by 2 by 3 power 3 into 1 by 3. So 3 and 3 gets cancelled, 2 and 2 gets cancelled. So that will give you 5 by 3. That will give you 5 by 3. Okay. What about this one? 3 power it's like a power m by a power n, which is a power m minus n. So 3 power 1 by 5 minus 1 by 3. 1 by 5 minus 1 by 3. So that will give you 3 power. If you take cross multiply LCM, 3 minus 5 by 15, 3 power minus 2 by 15. You can leave it like this. Right? All this we have discussed in the last class, right? So a couple of more things, and now let's try to understand what is a surd. What do you mean by surd? What do you mean by surd? Is that the same exponent? Maybe or may not be. There is some difference between them. Let's try to discuss what is a surd. If n is an integer greater than 1 and a is a positive rational number but not nth power of any rational number, then this is not n root a, this is nth root of a. Okay, nth root of a. Nth root of a, we read as nth root of a, or a power 1 by n, is called a surd of nth order. So there are some relations between a and n. A is a positive rational number. A is a positive rational number. That means 1 by 2, that is a positive rational number. Power, if n is an integer greater than 1, n should be an integer 1 by 2. 1 by 2 whole cube. It is an integer greater than 1. So these type of things are called a surd. It is called a surd. The positive nth root of a is called a surd or a radical. Surd, or we can also say it is a radical. The positive nth root. Positive nth root. This is also written as cubed root of 1 by 2. We already discussed that, right? In the previous classes where we learned squares and square roots, cubes and cube roots, then we learned what is cube and cube root, right? So it is a cube, this is not correct. It's not cube root. Let me erase this part. Okay. So a power 1 by n, it is a power 1 by 3. Let me correct it properly. It's not 3. It's not 3. It should be 1 by 3. Okay. It should be 1 by 3. This can also be written as cubed root of 1 by 2. This is written as a cubed root of 1 by 2. Here if you have 1 by 3, here it is 3. 1 by n here, and it is n here. So that is how you can try to differentiate. I mean, you can try to express in different forms. Okay, these type of things are called a surd. Let's try to understand more applications of surds. So when you're talking about surd, sometimes we write in a power 1 by n. This is called exponential form, which we have discussed previously. And sometimes we write nth root of a, nth root of a, square root. 2 means it's square root. Square root of a, cubed root of a, fourth root of a, 10th root of a, any number, right? So that is in the form of radical. That is a radical form. This is exponential form, a power 1 by n. So like 2 power 1 by 3, 3 power 1 by 3. So these are called exponential form, and this is called radical form. This is called a radical form. Okay. So let's move ahead to learn more about this one. Write the following surds in exponential form. Just now we discussed. Nth root of a is in radical form, whereas a power 1 by n is in exponential form. A power 1 by n is in exponential form, right? So root over 2. If no number is written here, by default, it is a 2. Meaning that it is a square root of 2. Okay, square root of 2, which is written as 2 power. This 2 will be written as 1 by 2 in exponential form. 2 power 1 by 2. This is a 9 power 1 by 3. What is 9? Again 3 square. 9 is 3 square. So 3 square whole power 1 by 3. So 3 power 2 into 1 by 3. So that will give you 3 power 2 by 3. That will give you 3 power 2 by 3. The same way, fifth root of 20, which is a 20 power 1 by 5. You cannot further solve that. You can leave it as it is. You can also leave it here also 9 power 1 by 3. That is also same exponential form. Even this is the same exponential form. And even this is also the correct one for fifth root of 20. We cannot further solve that. Okay. So let's move forward. Write the surds in radical form. So let's try to understand what is a radical form. Radical form means nth root of a. These type of things. Nth root of a, right? So it is 5 power 1 by 7, which is written as 7th root of 5. Which is written as the 7th root of 5. This is 1 by 6, 6th root of 17. 6th root of 17. This is 1 by 2. This is square root of 142. You can write this 2 or no need. So it is simply root 142. It is simply root 142. Right? 7th root of 5, 6th root of 17. This is a root 142. That is how you can try to express that in the radical form. This is in exponential form, and this is in radical form. This is in radical form. Right? So let's move ahead. Find whether variables x represent rational or rational numbers in the following. Okay. So what do you mean by that? Find whether the variables represent rational or irrational numbers in the following. So x square is equal to 0.02. X square is equal to 0.02. Okay. So we can write x is equal to 0.02 whole power 1 by 2. 0.02 whole power 1 by 2. Okay. So x is equal to 0.02. Can we express that in any other case? Can we write 2 by 100, let's say? 2 by 100, let's say. 2 by 100. Okay, we already learned how to represent that in terms of decimals. 2 by 100 power 1 by 2. So it is a 2 power 1 by 2. 2 power 1 by 2 by 100 power 1 by 2. 2 power 1 by 2 is a root 2, right? 2 power 1 by 2 is root 2. By 100, 100 is actually 10 square. 10 square whole power 1 by 2. We discussed exponents, right? So this 2 and 2 gets cancelled. It is a root 2 by 10. It is a root 2 by 10. Once again, let's try to verify that. X is equal to, this 2 will come to the other side, becomes 1 by 2. This 2 will be transformed to the other side, becomes a power 1 by 2. Okay. So 2 power 0.02 is 2 by 100 power 1 by 2. So 2 power 1 by 2 is nothing but a square root of 2. Okay. So that square root of 2 is an irrational number. You know that. Root 2 is itself an irrational number. So the entire answer is irrational number. The value of x in this equation is irrational. What about this one? X square equal to 7. X is equal to root 7. Although you get plus or minus. Okay. Root 7 is again an irrational number. You cannot express that as a rational number. X power 4 is 256. X power 4, let me recall 256, I can recall it as 16 square. As from my experience, I can say 16 into 16 is 256, but let us verify that. 16 into 16, 6 6 is 36, 6 1 6, 7 8 9, 16, yes it is 256. So, x power 4 is equal to, or x is equal to 256 power 1 by 4. 256 we can write as 16 square. 16 into 16, or I'll write as 4 into 4 into 4 into 4, which is 4 power 4. Which is 4 power 4. 4 power 4 whole power 1 by 4. So these two gets cancelled and we'll get the answer as 4. Right? X power 4 is equal to 256, where x is 4, which is a rational number. Which is a rational number. Right? Okay, so here it is irrational, here it is irrational, but in the last case it is rational. So let's move forward. Find the value of 64 power 1 by 6. 64, I can write 64 as 8 into 8. 8 as 2 into 2 into 2, and one more 8 as 2 into 2 into 2. So we can write this as 2 power 6, correct? So 64 power 1 by 6 can be written as 2 power 6 whole power 1 by 6, and we can write this as 2 power 6 into 1 by 6. So it is equal to 2. The value of 64 power 1 by 6 is 2. And 32 power 1 by 5. 32 we can write as 2 power 5. 32 I can write as 2 into 16. Correct? So 2 into 16 we can write as 2 into 8. 2 into 8, 8 we can again write as 2 into 2 into 2. So 2 into 2 into 8, I'm writing it as 2 into 2 into 2 power 1 by 5. So from here I can say that it is a 2 power 5. 2 power 5 whole power 1 by 5. So 5 and 5 gets cancelled. Answer is 2. 32 power 1 by 5 will give you the answer as 2. Clear? So let's move forward for the next one. Find the value of 46656 power minus 1 by 6. 46656, from where we can get this one? Okay, so let's try to divide with 6. Let's try to verify. 46656, let's try to verify, divide with 6. Okay, so 6 5s, 6 6, 6 7s, 6 7s 42, we are left with 4 again, 4 6, 6 7s 42 again 4, then 5, 6 7s 42 again, and we have 3 and 6. So 6 6 are 36, right? So this can be written as 6 into 7776. 7776 can be divided again with 6. 7776, 7 1s 6 1 7, 7 2s 12, 5 7, 7 9s 6 9s 54, 1 and 3 and 6, so it is again 6, 36. Okay, so it can be written as 6 into 1296, and 1296, I can remember that it is equal to 36 into 36. If you want to verify, 36 into 36, 6 6 are 36, 6 3 are 18, 19, 20, 21, 6 3 is 18, 3 3 is 9, 10. So it is a 1296. So what I can say, it is equal to 6 into 6 into 1296, we can write as 36 into 36. So 36 we can again write in 6 into 6. 6 into 6 into 6 into 6 is 36. Into this 36 is again 6 into 6. So total we are having 6 times the number 6. Okay, let me erase all this so that we can get some place to write. Okay, so now tell me what is the final thing we are going to write here. This is equal to 6 power 6 whole power minus 1 by 6. So 6 power 6 into minus 1 by 6, these two gets cancelled. We are left with 6 power minus 1, which is 1 by 6. 6 power minus 1, which is 1 by 6, right? So in the same way, we have one more question, 243 power 2 by 5. 243 power 2 by 5. How to write 243? Maybe 3 into 3 into 3 into 3 into 3, maybe. Or 4 or 5, not 5. Maybe 7 into 7. So let's try to verify with 3. Okay, so let me try what is a 3 into 3 into 3 into 3 into 3. 3 is a 9, 3 is a 9, and into 3. 9 9s are 81 into 3. 83 is a 243. 81 into 3 is a 243. So what is 243? We can write it as a 3 power 5. We can write 243 as 3 power 5 whole power 2 by 5, where 5 and 5 gets cancelled. We'll get 3 square, which is a 9. Right? So this is how you can try to solve all these questions. Very easy basic things. Right? So moving forward, we'll be having simplify. Okay, so we have many questions here. 4th root of 81 minus 8 into 3 cube root 343, 5th root 32, and root 225. 4th root of 81. How can you go with 4th root of 81? 81, I know it is 9 into 9. 81, I know it is 9 into 9. 9, I know it is a 3 into 3. And again 3 into 3. So we can write that as a 3 power 4. We can write that as a 3 power 4. What about 343? 343, let us divide with 7. Let us divide with 7. 7 and 343. 7 4s 28. We are left with 6. 3. 7 9s are 63. Yes. So it is 7 into 49. And 49 is again 7 into 7. So 7 into 7 into 7, we can write it. We can say that it is a 7 cube. We can say it is a 7 cube. What about 32? 32, we discussed that it is equal to 2 into 16, which is equal to 2 into 2 into 8, which is 2 into 2 into 2 into 2 into 2, which is a 2 power 5. Right? The same way 225, if you go for 225, it is a 15 into 15. Let me verify that. 15 into 15, 5 is 25, 5 ones are 5, 6, 7, 15, 5, 12. Yes, it is a 225. It is a 225. Okay, let me write that once again properly. 225, right? So now we have all the information available. I'm just writing the basic line from there. You need to start writing. Okay. So this step can be written as 3 power 4 whole power 4th root is 1 by 4 minus 8 into 343 is 7 cube. 7 cube whole power 1 by 3 plus 15 into 32 is 2 power 5. 2 power 5 whole power 5 plus root 25, which is 15 square. Root over 15 into 15. So from this information, you need to try to bring what is the final answer, right? So all the available or all the important information is given here. The next you need to solve from there, right? So next, moving ahead, we'll go for find the value of a and b, where it was given root 3 plus root 2 by root 3 minus root 2 is equal to a plus b root 6. You can see here, we have an irrational terms in the denominator. So let's try to eliminate them. That means that rationalizing. Root 3 plus root 2 by root 3 minus root 2. So I multiply with root 3 plus root 2 by root 3 plus root 2. We are trying to multiply this, okay? A plus b whole square, the numerator becomes root 3 plus root 2 whole square by root 3 plus root 2 whole square by a minus b into a plus b. A minus b into a plus b, that will give you a square minus b square. A square minus b square. So root 3 whole square minus root 2 whole square. So what is a plus b whole square formula? You know that? A square plus b square plus 2ab by Root 3 whole square, root and square gets cancelled, it is 3 minus root and square gets cancelled, it is a 2. So root 3 square is 3 plus root 2 square is 2 plus 2 into root over root 3 into root 2 is root 6 by 3 minus 2 is 1. By 3 minus 2 is 1. Okay, 3 plus 2 is 5 and it is a 5 plus 2 root 6. 5 plus 2 root 6. So we can carefully see that what is A? A is equal to 5, A is equal to 5 and B is equal to 2. Right? So that is about A plus B root 6. This method is called rationalizing. We are trying to avoid irrational term in the denominator. Irrational term in the denominator, correct? Okay, so let's move forward. So there is one more same type of question. So multiply with 2 root 5 plus 3 root 3 by 2 root 5 plus 3 root 3 in the numerator as well as in the denominator, and then you will understand the answer of A and B, right? Next one. Find the square root of 11 plus 2 root 30. Find the square root of 11 plus 2 root 30. So how to find here? So first thing, we need to know the basic relation A plus B whole square is equal to A square plus B square plus 2AB. Okay, so we need to express this into that form. Or what I'll do, instead of A square and B square, I'll directly take A and B only. So I need to find two numbers where A plus B value will be equal to 11 and AB value should be equal to 30. AB value should be equal to 30. So which numbers will satisfy this one? Sum of two numbers should be 11. So I can take 5 plus 6 where 5 into 6 is 30, correct? 30 is 5 into 6. So 5 plus 6 is 11. So I can use these two numbers to write 11 as 5 plus 6 plus 2 root 5 into 6. Now you can tell me, sir, what is the use of this one? So I can write this as 5 as root 5 whole square, 6 as root 6 whole square, plus 2 root 5 root 6. Now if you carefully compare A square plus B square plus 2AB, A square plus B square plus 2AB, the formula is A plus B whole square, root 5 plus root 6 whole square, root 5 plus root 6 whole square. The point is, find the square root of, so the final answer is, okay, square root of root 5 plus root 6 whole square. So square root and square gets cancelled and you'll be left with the final value root 5 plus root 6. So the square root of 11 plus 2 root 3. Square root of 11 plus 2 root 30 is given as a root 5 plus root 6. So this is how you need to bring the square roots. You need to make the use of A plus B whole square or A minus B whole square as per the requirement of the question. Here it is plus, so we're going with A plus B whole square. Right? So I hope you understood all the topics about SURDS as well as exponents. All these topics are very easy, but without the base logic, it will be very difficult. Right? So I hope all the real numbers concept is very well explained as well as you understood all this, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we'll be discussing about Newton's third law of motion. First law has been discussed, second law has been discussed. Now we'll go into third law. Okay, so my name is Shashan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. Okay, so let's go into a few examples and then let's go into the law. Okay, so the first example that we'll be talking about is this. Now you can clearly see a frog which is swimming. Yes or no? So how does a frog swim? Now when a frog swims, it goes forward. So who is pushing it forward? That is the question. And why only a frog? We can take us also. Even when we swim, how do we swim? That is the question. Okay, so what are the forces acting? We are interested in what? The forces acting in this case. Who is pushing the frog forward? Okay, so look at this. So what is the frog doing here? What is the frog doing? The frog is pushing the water back. It's like pushing the water back. Even imagine ourselves swimming. When we swim, what do? We push the water back. Yes or no? That's what we do. We push the water back. So the first force that is acting here is, if I write it down, frog is pushing the water back. So we can say that force by the frog. It's important who is applying the force and on whom it is applying the force. So force by the frog on water. Or you can write force on water by the frog. Anything is fine. So force by the frog on water, and the direction is backwards. Clear? No doubts. Then, see, that is the only force acting. Yes or no? Then how is the frog moving forward? Who is pushing the frog forward? That is the question. Huh? Who will push the frog forward? That is water. When frog pushes the water back, water will be pushing the frog forward. Frog is pushing the water back, right? And the frog is going forward. So who is pushing the frog forward? Water. Yes? So the second force is force by the water. By whom? By the water. And on whom? On the frog. In which direction it will be there? It will be forwards. So we can understand a few things from this. Between any two bodies, like I say, when frog is exerting force on water, then water will also exert a force on frog. There will be two forces. First force and second force. And the direction is opposite. Yes or no? If one force is towards right, the other force will be towards left. I mean, if one force is backwards, the other force will be forwards. So there are two forces acting. And they're acting on different bodies. Yes or no? On the first case, it is acting on water. In the second case, it is acting on frog. Two forces act on different bodies in opposite directions. In opposite directions. Clear? So frog is pushing the water back, and the water pushes the frog forward, and the frog goes forward. Even that the same thing happens when we swim. We push the water back, and the water pushes us forward. Clear? Good. Now we'll take another example. Now there is a boat. It could be a boat race. The question is, how is the boat going forward? Obviously, you can see the people who are rowing it. So how are the people rowing it? When they row, watch it carefully. When they row, what are they doing? They are pushing the water. When they row, they are pushing the water. And in which direction are they pushing the water? In this particular case, they are pushing the water towards right. Push water to right. Yes or no? See, watch them carefully. They are rowing it. Right? And when they are rowing it, they are pushing the water to right. And where are they going? In which direction are they moving? Motion is towards left. So the thing is, who is pushing the boat towards left? Who? Again, water. So how are the forces acting? Again, I can write first force. You can say force on water by people. In which direction? Let's say backwards. Right. If I want to go forwards, I push the water backwards. And second force is force on whom? Force on the people. And when I say on the people, people are in the boat, so force on the boat. So I'll just say force on the people. By whom? By water. In which direction? Forwards. Yes or no? That is what is happening here. So again, you can clearly see force. There are two forces acting. One force is on water, the other force is on the people. That means the two forces are acting on different bodies, and in fact the direction is also different. So opposite directions, not even different, they are exactly opposite directions again. This example. We have other examples also. Let's say, don't do this by the way. Okay, so when you hit a wall, here this This person is hitting what? Hitting his head to the wall. The question is, when you are hitting a wall, don't do that. But when you hit a wall, let's say by mistake, by accident, you have hit a wall. Does your hand pain? Yes, it pains. The question is, why? Which force is acting on you? That is the question. Right, so when you hit a wall, force on wall by us. Let's say this is the wall. Right, we are hitting the wall. So this will be the first force. I'll call it as 1. So force on the wall by us, in this case, to right. Simple. Then a second force is what? See, we are hitting the wall. So we are exerting a force on the wall. But why do we feel pain? When we hit a sofa, there is no pain. When we hit a sofa, when we hit a bed, no pain. But when we hit a wall, there will be pain. Why? Because here, in the second case, there will be force on us by the wall. In fact, in which direction it will be? To left. Opposite direction. So the other force will be on us by the wall. It will be in opposite direction, that is second force. So when you hit a wall, it is not only you who are hitting the wall is also hitting you back. So be careful. When you hit a wall is also hitting you back. So these are the two cases, two forces. In the first case, force is on the wall. The second case, force is on us. The forces are acting on two different bodies and in opposite directions. Right, now we understood them. We noticed this. And Newton observed them, noticed them, and from this he gave a law. From this he gave a law, and that law is Newton's third law. Okay, but let's again go into another case here and we'll summarize things. In all the examples discussed until now, we can observe that forces always act in pair. Pair in the sense two. Pair of scissors, pair of socks. Yes or no? Pair will mean two. So here always forces act, like two forces act together. So when a body A exerts or applies force on another body B, for example, let's say this person is A and the wall is B. So when A is pushing the wall B, when A is applying force on B, there is always, no exception, there is always another force that the body B, the wall, exerts on body A simultaneously. Simultaneously will mean at the same time, no delay. So if this person is pushing the wall will also be pushing him back. So you can see two forces, and those two forces are called action and reaction. We'll go into that part. But there are two forces in opposite directions and always. Right? It's a very important point. That's what Newton's third law is about. Okay? And Newton's third law is valid in all the cases that we come across in daily life. All of them. Okay? So what exactly is Newton's third law? Newton's third law states that for every action will refer to a force. For every force we apply, so for every action, there is an equal, very important, equal and opposite reaction. Understand this, action and reaction are forces, and mathematically we state it in this way. F12 is equal to minus F21. F12 refers to force on object 1 by 2. F21, the order is important. When we say F21, 21 is in the subscript. So when we write it that way, it refers to force on 2 by 1. It's a naming convention. That's important, okay, because that is the official way of writing it down. So it is important to understand what that means. And negative sign implies that both forces are opposite. Now let's say understand the same law using an experiment, using an activity. Again, let's say this is a wall and here there is a person Let's say that person is pushing the wall. So what forces act here? One force, the person is pushing the wall. So this is one force. So how do I write it? Force on the wall by the person. WP, force on whom? On wall. First comes on, then comes by. So force on wall by the person. Okay. First comes on, second comes by. Understand that. So force on wall by the person. Then that means there will be another force which is equal and exactly opposite. And it acts on the person. And who applies that? The wall applies it. So understand this. When I write it as FWP, what does that mean? First comes on, so force on wall. Second comes person, so force on wall by person. Clear? And then when I write it as FPW, it means what? Force on person by wall. First comes on, second comes by. So first comes on, force on person, second comes wall, for by wall. Simple. That is in naming convention. That is the meaning of the symbol. That is a proper way of writing it down. Good. So there are two forces which act on two different bodies. First force acts on wall, second force acts on person, and we give them names. One force we call it as action, the other force we call it as reaction. So action or reaction is not something that we do. No. Action and reaction refer to forces. Understand this. Remember this. What are action and reaction? Forces. They are forces. Right? So two equal. Now they are equal. What does equal mean? If this force is 10 Newton for example's sake, then this will also be 10 Newton. Equal. If this was, let's say, 99 Newton, this will be how much? 99 Newton. That means the harder you hit the wall, the more pain you will feel. Yes or no? If you hit it with less force, the wall will hit you back with less force. But when you hit it with more force, the wall will also hit you back with more force. Right? So be careful. Understood? Good. And they are opposite. Yes or no? See, FWP is towards right, FPW is towards left. So they are equal and as well as opposite. And we know that when we take coordinate axis, towards right we take it as positive x, towards left we take it as negative x. Same as a number line. Right positive, left negative. So opposite direction. Opposite to right is left. Opposite to right is left, and left we take negative. That means generally opposite directions are taken negative. Opposite directions are taken what? Are taken negative. So here what we do is, if FWP, if I write it as 10 Newton, we will write FPW as minus 10 Newton. What does minus show? Minus shows that it is in the opposite direction. Simple. Clear? So combining this, we can easily write that FWP is equal to minus FPW. They are equal. One is 10, the other will be minus 10. Simple. Got it? So that is the meaning of this. So in this very small formula, very small equation, there is too much of information hidden. So F12 is equal to minus F21. If you have understood that, you have understood Newton's third law. And it's a very famous statement, very famous quotation per se. For every action, there is an equal and opposite reaction. In everyday life also it is true. So for every action, there is an equal and opposite reaction. Understand this, action and reaction are forces. Are forces. Remember this point. Let's continue. Yes, that's good. So there are some points here regarding Newton's third law. It's not momentum, it is motion. Okay, momentum is wrong. It is Newton's third law of motion. What were the others? Yeah. Okay, let's continue. So here we have a few points. In fact, we have discussed all of them. But We'll again go into them so that you'll again focus on them, because there are some very important points here. The first point, action and reaction are forces, discussed. Second point, are opposite in direction, discussed. Third point, are equal in terms of magnitude. If one is 5 Newton, the other will be 5 Newton. If one is 1000 Newton, the other will be 1000 Newton. They are equal in magnitude. Then, they act on two different bodies. Most important. Here in our example, FWP is acting on wall. See, force on the wall. But the other force is acting on the person. Wall and person are two different bodies. So action and reaction act on two different bodies. So very, very important point, everyone. In fact, here I could say for most of the questions on Newton's third law, this will be the reason. Right, they act on two different bodies. Remember that point. In fact, all the points are important. That is much more important. Then action and reaction occur simultaneously. What does simultaneously mean? They occur at the same time. It is not like I am first and you are second. No. Both of them occur exactly at the same time. There is no first and second here. Okay. There is no time lag between the two forces and no third body is involved. So always you have to talk only in terms of two forces, two bodies. Here the person and the wall. Do not involve any third body. Don't do that mistake. Newton's third law, between two bodies, two forces, that's it. Okay. So those were some interesting points. Clear? So please go through them. Each and every point should be understood. Each and every point should be understood. Okay. We'll go into other examples and we'll try to visualize things, understand things. So now let's say book is placed on a table, and I'll tell you whenever it comes to Newton's third law, how to proceed easily. How to proceed easily, I'll let you know. Very simple tricks. Just follow a few steps. So book placed on a table. Now first thing you have to do is identify the two bodies. Identify the two bodies. So what are the two bodies here, everyone? Two objects or two bodies. One is the book. The other is the table. Book and the table. Those are the two bodies. First step done. That's it. Now, if I ask you what are action and reaction in this case, just write it in this way. F12 and F21. Now choose. You can say book is object 1, table is object 2. It's up to you. Or take book as 2 and table as 1. Doesn't matter. So when I say F12, what will it be? What is 1 here? 1 is book. So FB, what is 2? Table, FBT. And then F21, 2 is the table, 1 is the book. So FTB. These two will be exactly opposite. What are FBT and what are FTB? What are FTB and what are FBT? Let me write that down. FBT will be force. First comes on. So on book. Force. I'll just write it in this way. Force. On what? On book. First comes on. Second comes by. So force on book by table. Force on book by table. Then second comes FTB. Again, the order, on comes first, by comes second. So force on T. T is for table, on table. By is for what? By is for B. B for book. Force on table by book. Now, so what will the forces be in this case? The two forces will be, in fact, the forces will be force on book by table. How will it be? Imagine, force on the book by the table. How does the table apply force? Upwards. That is force on book by table. And how does the book apply force on table? Force on table by book. You tell me. I told you, right? Equal and opposite. So on the table, it will be downwards, FTB. That's it. See, we have got all the points. And if you want action and reaction, you can call this one as action. Take one force as action, the other force will be reaction. That's it. Okay, and you have got them also. Equal and opposite in direction. So we identified the bodies. That's the first thing you have to do. And I told you only two bodies, do not involve a third body. Now I have taken this example in particular because many people involve gravity, gravitational force in this. Did we discuss gravitational force here? If we follow these steps, you will not go wrong. Two bodies, take forces between them, one will be action, the other will be reaction, just draw it comfortably. Done, your answer is done. You got action, reaction, you draw them, everything is done. Okay, now I'll go into your doubt. So what about gravity? Some of you would have thought one force is gravity. Now understand this, gravitational force is applied by whom? Gravitational force is applied by or is exerted by the earth. And when I say earth, the earth is another body. It becomes what? It becomes third body. And third body should not be involved. Or not even fourth, fifth, any body. No. Only two bodies should be involved. So any third object, any third body should not be involved. Third body should not be involved. That is the reason why you don't even consider that. Forget about it. Never consider that. We only talk in terms of these two. Okay? And both of them are not gravitational force. Good? Good. Chalo. Now, some of you will be getting another doubt. If this is earth, let's say here there is an object. Any object, a body. We'll call it as a book. We'll take it as what? A book. Now what are the action and reaction? I'll again go in the steps. What are the two bodies? The first step is identifying the two bodies. Without that, do not go further. So what are the two bodies here? Book and earth. Book and earth. Then the second step is the forces. F12 and F21, right? So I can say F12, I can say book is 1, earth is 2. So force on book by earth. And F21, I can say 2 is earth and 1 is book. That means FBE, if I write it down, it is force on, first comes on, second comes by, B is first, B for book, force on book by earth. And which force does earth apply? This will be gravitational force. Understand it. That is what? That is gravitational force. So when I take the other one, FEB, that will be force on earth by book. Got it? Yes. So that means when I look at the forces on the book, how does the earth apply force? Earth will pull every object downwards or towards itself. So this is force on book by earth. You can call it as action. And the other force will be force on earth by book. That means earth is pulling us downwards. Earth is applying a force on us. Good. But we will also be attracting earth. The book is also attracting earth. That is part of the gravitational chapter. Then we learn that in the chapter gravitation itself. Okay, we'll learn that in which chapter? Gravitation itself. But for now, not required. But for now, identifying action and reaction are important. So this will be action and this will be reaction. Okay, so I think you would have understood by now the simple steps. Identify the bodies, then everything will follow. Identifying the bodies are important, and only two bodies should be there. No third body should be involved. No third body should be involved. Is that clear? So I told you action, the downward contact force on the table by the book. Yes or no? I think we discussed this. Force on table by book and force on book by table. Simple, action and reaction. So identify the bodies and then you can proceed easily. Understood? Good. So anything, and this can be action, this can be reaction. Or this can be reaction and this can be action. Action and reaction are just names. If you know the two forces, that is more than enough. Anything can be action, anything can be reaction. Good? Chalo, badhiya. Now we have many such examples, by the way, where Newton's third law is applicable, and it is the reason for many things to happen. The way we walk. Why are we able to walk? When we walk, imagine this, do this. Now only walk and see. When you walk, how are you applying the force? Everyone. When you walk, how do you apply the force? You push the earth back, and the earth pushes you forward. So there also Newton's third law is applicable. Everywhere Newton's third law will be applicable. And it will be the reason for many things. Okay. Now another one such example is this. Here you see the gun is firing a bullet. The bullet went forward, but the gun is coming back. We call that motion of the gun as recoil. Coming back is called what? Recoil. So why does the gun recoil? Now for that, let's try to understand. Let's identify the objects. Okay. We'll go into them. All that is summary. So when it comes to the gun and the bullet, the two bodies, the first step is identifying the two bodies. So what are the two bodies here? The bodies are gun and the bullet. The two objects, you can call them gun and bullet. Clear? Okay, then what will you do? You just, second step, forces. Simple, that's it. First step is identifying the bodies. The second step is writing down the forces. Just write FGB and FBG. Just change the order. What is FGB? First comes on, second comes by. So force on gun, by bullet. Simple. Then again same, first comes on, second comes bullet. Force on bullet by gun. Now understand this. How does the gun move? The gun goes forward. So the bullet pushes the gun forward. So force on gun by bullet is in which direction? Is in the forward direction. That means force, sorry, my mistake. It should be ulta. Force on the bullet is forward. So force on bullet is here. So force on bullet by gun is forward. Force on bullet by gun. Imagine this. You have a gun. The bullet is going forward. So bullet will push the gun forward. So force on bullet by gun is forward. That means force on gun by bullet will be backward. Because opposite direction. So the bullet is pushing the gun back. The bullet is pushing the gun back, and that is the reason why the gun goes backwards. So you identified the two forces, FBG and FGB. One of them is reaction, the other is reaction. Anything, it's up to you. Right? So on the gun, there is a backward force, and that is the reason why the gun comes back. The gun recoils. Okay? Because of this force on the gun by the bullet, the gun moves back suddenly, and that is called what? That is called recoil. Okay? So everyone, Newton's third law, that's what we have learned. It's a very important law. Understanding it is very crucial. There won't be many numericals, but reasoning questions you will get many, right? So that is the reason why you have to understand them very carefully. That is one of the basics of physics. Okay, so do practice and understand it. Okay, so thank you, thanks a lot.